This conference will now be recorded.
So what we learned in our previous class? Yes, we learned about the architecture, how it will form. No? So we understood the neural network architecture. If I have the input like this, okay, and if I have the output like this, sorry, and what things are going to be happening between my input and output, right? So that is what we understood here. So it depends upon the scenario to scenario. You are supposed to change your weight matrix. Okay, I mean, initially, according to the input matrix, you have to produce what hidden layer construction should be there. After that, once you understood that what hidden layer construction, how much of columns are required, according to that, you are going to create your table matrix set, which is randomly generated, right? So after doing multiplying of those x and w, what we will receive? We will receive actually h. On top of h, yeah, you will apply again function, any function which we have in the deep learning subject. Once we put function, what the values are generates, those will be saved in the hidden layer construction, right? Once that hidden layer construction is done, again it will check up what is my output. Y will be your output, and it contains like 100 by 1 columns. So what we need to do again, according to the Y values, okay, and according to the H values columns, I need to reproduce W2 values as well. This means again random generation of W2 values. So 5 by 1. So 5 gone, and you will get what? Y hat values. On those Y hat values, again, yeah, you have to put your function. Then only it becomes exactly Y hat. Before that, it is just a multiplication, right? Yeah, I should not say Y hat. It's just a multiplication on these two things. That is what a summation it has done. Now you are applying an activation function, which produces Y prediction values. Now comparing those Y actual Y predictions, what are the learnings that you have to do it. That's it. Right? Yes, I also mentioned about this one. So yes, so when we are doing forward, I mean creating the random values and making updated and closing that error is what feed forward. When I go back and rechange my weight to values and weight one values and rerun this thing, entire thing, is what called back propagation method. Back propagation method. Hope did I explain this feed forward and propagation yesterday? Did I told something on this? What is feed forward back propagation? Did I told? I not remember. Told, right? Yeah. Okay. We'll go little depth to understand more about these things. Just a minute. So here, yes, I already told here, I guess, log loss for classification, mean square error. So these things, this y minus y hat here always will be called as what? Loss function. That means what? Actually, indirectly, error. So instead of speaking as error, sometimes we may speak as loss function. You should not confuse what is this loss function, the error, the difference. So you are working on this error and you are going to take the decision that how much loss function that we received. So what we are going to do is what is your intention to reduce this error between y and y hat. But what happens in the feed forward? For the first time, this error won't reduced. I think I told to listen the gradient descent classes. Did you recollect those things yesterday? Chetan, Pallavi, Sindhu, did you review those classes? Chetan says yes, sir. How about others? Sindhu also says yes. Okay, good. So you are able to recollect. So no need to worry for me again. Okay. So why I am talking about those things, gradient descent here is, that's what I said. Our intention is to reduce the error. So when I randomly generated the values of W1 and W2, so it is a random generation values. So obviously, I don't know how my error looks like. Looks like in the sense, very big error or very small error. Right now, in your machine learning techniques, it was not like that. You applied a statistical formula, x transpose x whole inverse x transpose y. With those, directly you are going to get the closer values. And we don't have an alternative way. But when you recall, if you recall your gradient descent method, okay, what we have done, we applied a derivative path. Look what this is, I mentioned here. It's not there. All right, no worries. Let's go back there. So what we have done, we applied a derivative method to the back of your mean square error, right? We applied a derivative method to the back of your mean square error. What is your mean square error formula? Y minus y hat whole square divided by n under square root. So of course, this formula derivative we are applying on the gradient descent, not on the square root, removing the square. That means only just y minus y hat whole square by n. That's it. So once you apply this d by dx on y minus y hat whole square by n, we will get some output. That output makes us help, okay, to recreate your coefficients and pull back your gradient descent line towards upwards direction. Right now, that outputs makes us, that means the derivative function helps us to recreate those weight values, coefficient values, okay, towards plugging into the, I mean, our line, the regression line to be put into a right place instead of, because gradient descent, what we do, it will randomly, it will place it somewhere initially. So after applying derivative technique on your errors, it will mode slightly. So to making you sure, I also not make clearly understand. I am also not able to make you clearly picturize what I'm trying to say. Yes, initially it was like this. So after applying our I mean derivative technique, this line will be keeps on moving like this. Now the error is getting fallen down. So after some iterations, you could see a line will be produced somewhere where you have the minimum error possibility. So how this is happening? With the help of derivative. Okay, if you keep on making changes the coefficients, what happens, it is going to overfit. So we need to understand where your line gets the best fit line. Nah? You want to recollect? So how it was happens? If you go back, I mean, yeah, to find out the best slope, we'll apply derivative on each equation. I think I also shared this PPT along with for you guys to mix better understand, right? We'll apply derivative on each equation, right? So this derivative will make us a proper coefficient values. Yeah, sum of squares of residuals. I'm not taking the square root. If I take the square root and divide by n, what becomes? Your mean square error. So here I'm taking only working on the residuals, errors. All right. So d by d intercept of these things. D by yes, chain rule, these all things forms. So similar to this concept, here also we are trying to work on errors. So these errors will keep on changing their weight values. That means your past values weight here and there. So a big logical calculation is going to be happen. Okay, so that's what I would like to tell you here. And yes, so here what is our loss function? This one. So if you are using this one, yeah, on those errors you are applying derivative. If you are using regression or classification, any of the technique, yeah, you are applying this derivative method on loss function. Okay, so yeah, that's what is going to happen. Now let's go with some more things. Just a minute, I'm just recollecting the things. Suppose if I take an example that we solved our NLP code, how much data we have in that example? This one, we worked on this one, right? So if I have this one, so we have 5 rows and it should be 6 columns. I remember once you separated these words. Okay. So here it will be your input matrix will be, let's say your input matrix will be 5 rows, 6 columns. Okay, let's imagine and this is it will be your weight matrix. And here if I apply hidden layer, so what will be our hidden layer? If I have 5 rows, 6 columns, what will be our hidden layer? So as I say, hidden layer should be 1.5 times. So I have 6 columns. So how many columns? 9 columns, right now? So 5 by 9 columns. All right. So in between those, now if I want to multiply and apply activation function, what weight matrix should be generated? Six by 9. 5 by 9 or 6 by 9? 6 by 9. Right now? Then only this 6 will go on and 5 by 9 will come out. Agree? Next one, again W2. Yes, so my Y is, sorry, my output Y is output contains 5 by 1, 5 rows, 1 column. So what to be multiplied here again? 9 by 1. Right now, 9 will go out and 5 by 1 remains. Right? So this is the how the way procedure of a construction will be happen. Okay. So how you are going to write to feed forward or back forward. So for example, as I say, if I am talking about feed forward, for the first time only what random values will be created, that procedure is going to be happen, and that is what the error. But when I want to rechange your weak values, so the question is how many times that you need to change it? 5 times, 10 times, or 100 times? That you cannot decide, na? Because until unless my error completely goes down, till that moment I need to readjust my weights or not. Understanding what I'm talking? Until unless my error completely goes down, I need to readjust my weights or not. Is this point is clear? So that means how many times I need to change my weights to get that my error completely goes down? No idea. Agree? No idea. It may be 10 times or 100 times or 1 lakh times. So that's why what we are going to put, we need to consider under everything into one loop. Right now, for suppose I in range, I need to put into some loop. Okay. So here, how we are going to write up all these things? Step 1. So initially, yeah, you have to create an activation functions and all those things. So if I apply forward, let's say forward, feed forward method. Okay. So the things what you have to create is creation of layer 1. That means hidden layer. Okay. Using, so that means what you are going to create a dot product, a W values, creation of using W1 and your input matrix. Right now, this is what has to be going to be happen, and on top of this one, I have to write like this. Maybe you will get confused, right? So on top of this, you are using function creation of L1 using function on these two things. Clear? The same thing, creation of L2 between what and what? Your let's say L1 and W2. Is it clear? What I written here, is it clear, everyone? Creation of L2 when I'm doing. So now your input is L1 and W2 values will be happens. Here creation of L2 means not layer 2, whatever the next step. So I did not mention the layer 2 discussion here, but you can imagine that what it produced from layer 1. This is layer 1, right? So what it produced from the layer 1. So layer 1 into W2 gives what exactly? You can imagine like that. Okay, don't confuse the things. Or else you can write y creation of y hat. If you are confusing, yeah, you can take like this. Should not confuse. All right. Okay. Now, how the step 2? That means now what happened? You have done your feed forward method. Now I have to go backward method. Na? So how this backward method? Now first you are supposed to calculate what? Calculation of error where between y hat and y. Na? You receive here error. I will write as error 2. I'll tell you why I'm writing as error 2. Now y minus y hat. That is what I'm talking here. Calculation of error 2. Okay. So here I'll call a weight adjustable thing. Na? So I need to adjust the weight. So where I need to adjust this one? So you need to apply derivative on your loss function. So what is your loss function? The error values what you have done here. Okay. So that formula, okay, that formula will makes adjusted your weight values. So here it will be typical to try to understand. It will be a little bit typical to what to say, imagine the things while doing the code. You will get properly digested. Okay. So think logically. Just a minute. Yes, apply derivative on loss functions. Okay, so I will call them as I will call them it as that derivative okay, yeah, L2. I'll call as L2. So this derivative produces a result and I'll call as the D2 and your E2, that is error 2 values into derivative of your L2. That means what? The derivative function what you applied on your loss function. Just a minute, guys. Let me think. Just a minute, guys. Let me think. I'm also nowadays this topic is not recorded by myself. So long back I have prepared this one, so not able to recollect. We can also do this thing directly in writing with Keras package, but instead of directly running with the Keras package, I would like to produce a manual calculation. That's what my intention. Okay, so that's what the theory. So if I want to produce this through Keras, I can directly have the answer like this. So without using the Keras, I would like to do the things. So to write these functions like this, simple. It will be cover up everything. These few lines will cover up everything. But what I would like to do is actually, I would try to write the code of this one. Yeah, this kind of loop. So I'm just thinking on how to explain. Yeah, this should be layer 2 creation of y hat using function of L1 and W2, right? Yes, it is correct. So this should be y hat. Okay. So apply derivative on loss function, and this gives, yes, whatever the values that we got here, I'm using as y hat now. Yes, multiplying with your errors, which gives what? A D2 values. I'm calling as delta 2. In fact, this will be called as delta 2. Okay. After doing up this one, step 3. So what you are doing here? We'll do one thing, guys. I need to recollect this theory again. I need some more time. Okay. So I need to stop for today. Let me recollect this thing today. Can we conduct this class by today evening sometime? Do we have some time? I don't want to compromise with the least quality of explanation. If I want to do, I could have go with, as I say, with the Keras package with this one. This one will make everything. But I don't want to go with like this. I like to go with the this method first, and then after that this method. That's what my thought of implementation. If I want to explain, I can directly explain this and I can complete it. So nothing is there. So this is input layer values. Here hidden layer values, functions. Okay, output. These errors. If I rerun these things, things are done. But I don't want to go with directly. I would like to explain this coding part how we have done. So I need some time to again recollect these things. So how much you are free today evening, like 8 p.m. something? Or if you want to be update, you can. Okay. So let's stop for today. Let me recollect again properly. Yeah, because if I make confuse, there will be a lot of confusion that will be disturbs in your mind. So we'll go with the proper way only. 1 or 2 times it gets delayed, but let's go with the proper way only. All right. Okay. So let me stop today. We'll update you about evening time. Okay. Done, guys.